Click on the column, only one group for the column. You can right click, design using Tekla 10 group, or export to the group. Now click on the design as group. I will compare you what is friend. You see here, when you design using the option, it is automatically designed and updated directly in Tekla Structural Designer, but it is difficult to check on the level. Only one section segment and the total length. So we can find what is the main reason called the column fail. Now I do not use the option. Come back, click on OK. Right click on it again. We have to check it first. Export to the Tekla 10. When you export to the Tekla 10, the Tekla 10 can be designed on each level of the column. You see here, there are three levels. Level 1, level 2 and level 3. Double click on the level 1. Check the summary result fail because the supply partial capacity. So we can switch on the reason, the supply. Okay, right click. For other design ratio is okay. The capacity ratio partial bending is only 24%. Right click, calculate bar 25mm diameter. So we had to change it. I use only 16 and choose the amount of the rebar 222. The preview result, the critical load. You see the design ratio, the design control is the partial bending. The interaction include the axial force and the bending moment in both directions. The design ratio is 0.62. It says less than 100% or less than 1. You can optimize the section. Now I keep it in the default 350. Output, we use the full option. Click on the listing detail. This is the portion input the list. You can change the total length of precast element. Now I keep in default. Click OK. Include column supply. Yes, this is what we want to find. The column supply. Well, click on the column supply detail. Bar parallel to the Y and Z direction is the same as the main bar 2 to 16. Correct cover 30 cm. Inequality of the bond condition, I use it good. Consider the preview result supply 1. The supply 1 partial capacity 1.48 frame moment about the Y and Z axis. Come back, click OK. Click on the console. OK. We do not yet complete this analysis design. We have to check on the tubular data. Summary only concrete. Click on the concrete. Click on the column. And click on the wall. I want to show only for the column. The alpha critical is very high, greater than 10, so the structure is non-sway. So the column design the prepress is correct in both directions. Come back and continue to the analysis design column. Click on the 3D. Is the alpha critical less than 10, so you have to select all the column and change during modeling. Change it to the pressing. It's meaning unpressed column, and you can change in direction 1 or direction 2 or change in both directions. Okay, come back. Click on the envelope to check the maximum envelope force. We use the envelope. Change the result to the measure and minor axis to find the maximum bending moment on each direction. Now we keep in the moment minor axis. Click on 4 to show the value. The maximum at the top of column at the rows is minus 12.4 minus 12.8 this one 12.8 green suit. Minor, we use this internal for apply for all columns. Actually we should apply it differently on the level. Now I keep this one, use the maximum to apply to other supply. Check on the moment measure axis. Click on the moment measure axis. No moment measure axis on the column. Click on the column. Right click, export to Tekla 10 or come back, click on it. Now I choose the maximum minus 12.8. At the direction I input 0. Click on the preview result. Change the projecting bar incorrect length. Minimum is 550 mm. Now I keep it 600. It's okay. Click OK. The listing detail we design it. Click on the finish. The result no warning, no fail element. Double click on the column. Level 2, right click, calculate. We use the same process. We choose the amount of the rebar. Input direct here 16. Include the column supply. Okay, I use the same maximum for 0. Preview result and change it to good. It depends on the quality of bond condition. If the bond condition is not good, the incorrect length capacity ratio is 0.92. I use 600. It's not pass. It's lower than required. You can choose the not good bond. Okay, now you good. So the capacity ratio for incorrect length is 0.9. Click OK. Click finish. Double click PC13. Right click, calculate it again. Change it right here. The diameter of the rebar. Include the columns at the top. The internal floor is higher than the column at the ground floor and at the middle. The maximum bending moment is 12.8. The bolt curvature, ground floor single curvature. The maximum is 6.3.3. And at the top, the maximum is 12.8. Single curvature. And this one is double curvature. Change the moment capacity Z direction. Increase it to 3. It's okay. Click on the finish. So you know how to fit the file elements. You can print it to the PDF. Property. Change the paper size to A4. Okay. Portrait. Can change to the landscape. Okay, and print it. Now seal. Seal it. Seal. 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 Okay, come back. Click on the review view. Remaining the red color. When you export to Tekla 10, you see the option. You can check a design in Tekla 10, but not in Tekla Structural Design. So now you have to use the option. Design using Tekla 10. Right click. Design using Tekla 10. Group. You see the color here. Start from the ground floor. We input the information for the ground floor. GL. And the extended continue to the first floor. And the last one is the roof floor or at the second floor. So remember and check the represent color here. Close. Now I input the 16 direct here. Diameter bar and 2. Supply, I change it to the gold. 600. 12.80. Click OK. Design based on the UK National Net. OK. Output full design report. OK. Finish. Option here. Yes, the color represent the selected column. I use it 16. 2. Include supply. I use the maximum for apply. The same on the column. 0. 600. Detail. Okay. Good. Preview result. Click OK. Click finish. Yes. the last floor. Now we keep it 16, and this one we use 3. This one we keep it 2, and include supply 600. Good. 12.80. Preview result. Click OK. Click finish. For the column group CPC1, there are 105 members. Now everything is working fine. You can see here the color. Seal it. Don't forget to seal. Check on the status. The status pass. 275 members. Warning. Only 4 members. Okay, warning. And for the ratio, it's okay. The ratio for the column is around 9% to 100%. Now continue to foundation design. Click on the pad base column. Click on the pad base column. Select. Click on the auto design deep inside. The software will be automatically design the deep and width length for you. Use the auto design option. The length 1.8 meter, don't worry, and the deep you can keep it for, and the software will be calculate and optimize it. We use the concrete 32. Okay, keep it. In the sliding in a y direction and in direction, if the footing is below the ground, you can use the option. No prevent overturning. The option should untick. Okay, only sliding you can prevent it. You keep the bar diameter 12 and spacing 120. 120 bar diameter 12. Yeah, the cover we keep it 40 millimeter. In the building capacity also you 15 tons. 15 tons. C-charge, no C-charge apply on the footing. Click on the design strip base wall. Select. 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 Seal. Click on a design pad base foundation or the footing. Pass all 43 elements. You can check for the review and the ratio. Okay, the ratio is 9 to 100%. You can take the mouse over here to check the ratio or check on the element. Right click. Check member. The bearing capacity is span all. The bearing capacity utilization ratio is 97%. Summary. Okay. Thank you for your watching. I hope you enjoyed this tutorial. Thank you.